Hi everyone, just wanted to take a minute to talk a little bit about right triangle trigonometry, which is going to be a method that we're going to use to be able to solve for a different side of any right triangle. Um, Now you might be asking yourself, well, why not use the Pythagorean theorem or something like that, or any of the special right triangles we already talked about? But this is what we're going to use when we don't have all the information for the Pythagorean theorem or to use a special right triangle. Um, and essentially, this will kind of work in every case scenario now, as opposed to just the specific cases. So let's go over what our goals are. So our goals are we're going to be able to determine the side lengths using trig, and then we're going to talk about the different trigonometric ratios. So there are three main trigonometric ratios that we are going to be using. They are called sine, cosine, and tangent. Um, when we write them, we're going to be writing them in this manner. We're going to be writing, I should have started with sine, sorry. We're going to do sine of theta. We're going to do, cosine of theta. There it is. And then we're going to do tangent of theta. So even though this looks like sin, you're going to say sine. It's not cos, it's cosine of theta. And then tangent of theta. All right. Theta is going to be the angle that we're using. So when we're talking about these trigonometric ratios, we're going to be talking about them in relation to a specific angle. So as you can see here, if we talk about this angle over here, we'd call this one theta. We're talking about this angle, we can call this theta. And where theta is will affect our ratio. But for right now, we just need to know that we have sine, cosine, and theta, and tangent, sorry. Now, when we set these up, as I just said, we are going to have a difference in terms of what is considered opposite and what is considered adjacent. Okay? So, sine of theta is always going to be opposite over hypotenuse. All right? So here I have a triangle. And if I'm using angle A as theta, the opposite one will be the one all the way across, right? X. See, this is the opposite. And the hypotenuse won't change, right? The hypotenuse is always the hypotenuse. So depending on if I'm talking about angle A or angle B, the opposite would be either X or Y, as you can see here. So we have opposite is X, hypotenuse Z. Opposite is Y, hypotenuse Z. And that depends on which angle I am using. Similarly, with cosine, we're dealing with adjacent over hypotenuse. So if I look up at my triangle here, the adjacent side is the one right next to the angle that's not the hypotenuse. All right. So for example, and if we're using A, the adjacent one will be Y, and Z is still the hypotenuse. If we were using B, the adjacent one would be X. All right. As you can kind of see, these are flip-flopped. Finally, tangent is opposite over adjacent. Right? Tangent of theta is equal to opposite over adjacent. So this one will completely change depending on which one I'm looking at. If I'm looking at A, right, we have X over Y, but if I'm looking at B, I have Y over X, right? So be careful because opposite and adjacent does change depending on which angle I am looking at. All right. There are three more trig ratios that we really don't use for the purposes of this class. They come up a lot more in later mathematics, but for the purposes of geometry, just kind of know they exist. So we have sine, cosine, and tangent, and then the reciprocals of those will be cosecant, secant, and cotangent. All right, so they do exist. We're not really going to be using them. So for example, sine of theta is opposite over hypotenuse. Cosecant of theta would be hypotenuse over opposite, right? They're just flipped. Similarly with cosine and secant, and then tangent, cotangent. You'll just take the normal thing and flip them. So how do I actually do things with this? Well, what we're going to be using is, as I said, these ratios. So the important thing that we need to remember is that sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and tangent of theta is opposite over adjacent. So what we're going to be doing is essentially a good way for us to remember this is something called SOHCAHTOA. So S-O-H, sine opposite hypotenuse. All right, so we have sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. All right. So if you can remember SOHCAHTOA, you're going to remember how to solve most of these problems because this is going to be the ratio that you set up. All right. So for example, if we're trying this, it tells us in this triangle, it's a right triangle. We know that angle E is 46 degrees, and this is 91. And I'm trying to find the length of the hypotenuse. So I have an opposite and I have a hypotenuse. So I need to ask myself, which one of these has opposite and hypotenuse, right? So if I'm kind of going through, right, here I have TOA, T, so I want the O and the H, right? So I need the first three, sine. So I'm going to use sine. And I'm going to use the angle I have, right? Normally I'd write sine of theta is equal to opposite over hypotenuse. So let me identify that piece of information, right? I have the opposite. What's my opposite? 91. What's my hypotenuse? Well, I don't know, it's x. And then sine of theta is sine of 46 degrees. All right. So now you're probably looking at this and going, well, what do I do with this? So sine of 46 is just a number. All right. So if I go to a calculator, okay, I'm just going to Google, go to the Google calculator. You'll see it's available right here. Now, I was doing sine of 46 degrees. So up here, you'll see there's a rad and a deg sign button. You're going to make sure it's on deg, which just stands for degree. So I'm going to do sine of 46, and right, it's in degree mode. So it's just a number, okay? This is what it would be. It is 0.719, all right? So it's just a number. So I can manipulate it the same way I would manipulate any other number, right? So I can add it, subtract it, multiply, divide it. So I'm going to, multiply both sides by x, multiply both sides by x. Now I essentially have x times a number. Okay, equals 91. Now I'm just going to divide it, right? This is a number. We just looked at it. It's not 0. So I can do this. I can divide. All right, so I get x is equal to 91 over sine of 46. All right, and now what I'm going to do is I'm going to go back. I'm going to plug that in. Okay, so let me just make sure. I'm still on degree mode, right? Don't forget you need to be in degree mode. So I have 91 divided by sine of 46. Just be careful with your parentheses. And my answer should be 126.505. I forget what it told me to round to. 126.5. All right, so my side length here would be 126.5 feet. All right, so simple enough. Really, all we're doing here is we're just plugging it in, and then it's a number. So I'm then just solving for my x, okay? So let's do another one. All right, so now we have something like this. I have my angle here, I have my opposite, I have my hypotenuse. So again, I need OH. So I'm going to set it up. I know sine of theta is equal to opposite over hypotenuse. All right, so I have sine of 76 degrees is equal to x over 7.3. Multiply both sides by 7.3. I get 7.3 times sine of 76 degrees is equal to x. Again, I'm just going to plug that in. I still am in degree mode. Sine 76. There you have it. I had 7.1. All right. So these are, once you get the hang of them and you know what they're looking for, they should be relatively straightforward because you're pretty much going to go through the same process every single time. Okay. The only annoying thing is sometimes if you need to solve for the tangent, if you need to solve for the hypotenuse, you can end up with an x in the denominator, which does require just one extra step, as I showed. All right, let's do another one. Let's take a look at this one. So here I have my angle. This is my theta. Okay. Here's my adjacent side to it. It is adjacent, and here's my hypotenuse. All right, so I need the one with AH. So toa. So I need the AH, which is right here with the cosine. So I have cosine of theta is equal to adjacent over hypotenuse. Okay, so I have cosine of 78 is equal to x over 35. So 35 times cosine of 78 is equal to x. All right, so let me just plug that in. I already forgot what I was about to plug in. 35 times cosine of 78. All right, 35, cosine of 78. There you have it. My answer is 7.3. Again, you need to be careful. I am still in degree mode. Make sure you stay in degree mode. Okay, so my x is 7.3. All right, so continuing on. Let's do another one. Oh, here what do we have? We have an opposite and an adjacent. So we need O and A. So we have toa. All right, so I need the O and the A, tangent. So tangent of theta is equal to opposite over adjacent. Right, here's my angle. I need the opposite, which is 26. So tangent of 25, there we go, equals 26 over x. Okay, so again, tangent of 25, it's just a number, so I can still add, subtract, multiply, divide. So I'm going to add, times x. Right, so this is one of the situations where you have the x in the denominator and it makes things a little bit harder. So I get x is equal to 26 over tangent of 25. All right, so again, the reason I'm allowed to do this is if I, take a look at it. Again, I'm still in degree mode. Tangent of 25, it's just a number. 26 divided by tangent 25. All right, so 26 divided by tangent 25. And there we have it. My answer would be 55.8. Okay. So x would be equal to 5.8, and then it's in feet. Be careful. These drawings are not always to scale. Obviously, this one is not to scale. This is 26. This we just showed was, 50, basically 56. All right, let's do another one. So what do we have here? Oh, I have another opposite and another adjacent. So that does mean I'm going to use tangent. So I have tangent of 85 is equal to x over 4.6. So x is equal to 4.6 times tangent of 85. Right? And don't forget, this is in degrees. Because it's being measured in degrees, we're still doing degree mode. 4.6 tangent 85. Okay, so my answer will be 52.3. 52.6. Just read the wrong number. So my x is equal to 52.6 feet. All right. Now, last one. What do we have here? We have an opposite. We have a hypotenuse. So we're going to go back with the opposite and hypotenuse. That's sine. So I have sine of 18 is equal to 6.1 over x. Multiply both sides by x. I get x sine of 18. Oops, I forgot the 1. 6.1. X is equal to 6.1 over sine of 18. Okay, so we're going to plug it in. I'm still in degree mode until I stop measuring in degrees. 6.1 divided by sine of 18 is 19.7. All right, so my x is going to be equal to 19.7 feet. Now, there's a couple ways that you can, just in closing before I head off, there are a couple ways you can kind of check your answer, so to speak. So if you get an answer for the hypotenuse that is shorter than your other side, something went wrong. If you get something like this is 75 degrees and you get this is like 13, and then you somehow show me that this is like 20, that's also a mistake, right? Because the bigger the angle, the bigger the side. So if you get a number here, see how this is 18, it's smaller than 45, that means the other side down here will be bigger than that. If you had a number bigger than 45, that would mean the other side would be smaller. Okay, so that just comes from the triangle inequality. So just, dealing with triangles and inequalities, I should say. So just be careful with that. But let me know if anybody has any questions, and have a great day.